So today I'm going to be talking about our lab that we did this past Friday. And what it was about graphing constant velocity. So pretty much what we were to do was to calculate the toy's car constant velocity. So this lab has been split up into two parts, and I will be doing this video on the first part. Now, what we were given a meter wheel, a toy car, and a few timers. Now, the procedures ask us to form a group of four and 4 or 5 people. Unfortunately, we couldn't get another person, so we ended up doing 4 checkpoints for the toy car. And what we were to do was to measure the toy's car's velocity, and we were to find the velocity by seeing how long it took the toy car to get to each checkpoint. Now, each checkpoint were spread about a meter apart. So what we did was we got 3 trials for each time the car went by, and see right here our distance. Right here we got up to 4 meters, and these are our 4 checkpoints. And this right here are 3 trials, and pretty much what we did here was we averaged them out so we could get a more accurate standpoint on our results. Now, after the lab and after our data collection, we were to graph the data on a graph, and pretty much what we did was we put the data position of we put that on the y-axis, and then we put the average time on the x-axis, and then after that we were to draw a line of best to fit, and then we were to find the slope of that line. Now our instructor asked us to keep the units when calculating the slope, and I was kind of like, why is she asking us to do this? So we're doing this because we're calculating velocity. We're calculating how long it's taken the car to get to a certain position. So we're finding the change in distance over the change of time, in which that will end up equaling the velocity. That's why we keep our units, so we can see how fast the car is going per second. So right here, for our graph, we got, let me see. So right around here, we have our average time of the car, and then we had our data position. So what we did was we plotted the points, and then I grabbed 2 points right here, and I can't really zoom in that great. I apologize. It's all in the Google Doc. So I got the change in distance over the change of time, which was 2 minus 1, and then over 4.7 minus 2.3, which were my 2 points I decided to collect, which were from the first and second checkpoints. And so I got that meters over seconds, and then our velocity ended up being about 42 hundredths of a meter per second. Yeah. So that's what our lab was pretty much about, and a few things that could have gone wrong in the lab. The car tended to kind of veer off in a certain direction that could have affected the timing of the times that we collected at each checkpoint, because we consistently had to keep veering the car so that it tries to continue to go in a straight line. That could have affected the results that we got on some of our checkpoints. Also, we could have had a little bit of an error by calculating at what point the car ended up crossing the checkpoint. That was pretty hard to accomplish. So that could have been one of our errors as well. Also, the surface of the ground could have been a factor as well. As you see, the surface of the ground creates a friction between the car and the floor itself. So the material of the ground, which is a tile, even though it's pretty easy for the car to get across that, as if it were on carpet, it would have been a lot different of a scenario. So yeah, those are the things that could have affected our experiment, and that's pretty much what we did in the first part. Thank you for watching, and have a good day.